So we are going to learn how to do naming of binary compounds in this video. And so for this, you're going to need a couple things. You're going to need the periodic table to refer to. And you will also need what we call the ion chart that we have given you. Okay, so you need both of those in order to do this. So with binary compounds, we're always going to name the cation the name of the element. So you're going to use your periodic table for that. You're going to name the second one, which is the anion, the name of the element. You're going to end it in "ide," I-D-E. The subscripts are not going to be used in the naming. And again, that doesn't mean anything to you right now, but it will when we get to what we call molecular compounds. So that's why that is an important statement. So when we are doing binary compounds to the name, we are going to be given a formula, and then you're going to have to figure out the name. So what I'm going to show you is how to break it out into cation and anion. You don't have to do this portion, but it will be helpful for some more complicated naming as we go forward. So with that in mind, the potassium is in the first column on the periodic table. So that is a +1 charge. And the anion is Cl. Cl is over here. It's number 17. It is in the column of -1. And we probably already know that by the fact that this is a 1-to-1. So K is called potassium, so we call it potassium. And Cl is chlorine, but it ends in "ide, so I have to change it to chloride. And you probably know that from sodium chloride. We know that name, so that could be something you could pull from. So Li2O, okay, so the 2 doesn't affect the name, but the Li2 is because lithium is in the first column. It is a +1 charge. And oxygen is over here on the right. It's in the -2 column. So that is why it is a +1 and a -2, and that is why you have 2 of them in the formula. So I have to name it. So this is called lithium. So that's always the first element is the cation. And then oxygen. It's not oxygen. I have to end it in "ide." So it's not oxygenide. It has to be oxide. Okay, so that's the name for that. So see if you could do this one. So Ca is calcium, P is phosphorus. So see if you can name it. I'm going to pause it and get the answer. So the answer is it's calcium phosphide, phosphide. So again, all of these must end in IDE for the binary compounds, okay? So again, me writing out these charges probably makes no difference to you at this point, but it will for this next section. So we have what we call some transition metals. These are going to be the metals that are in the middle block of the periodic table. So this block here is called the transition metals. These are metals that have what we call multiple charges when they become ions. So these are the ones that are on your ion chart, and that's why these are going to be so very important for you to use. So I'm just going to focus on the ones on the left. We will talk about these on the right. These are called polyatomics. We'll get to those later. But these on the left are what we call the transition metals that have multiple charges. So like copper has a +1 charge and a +2. Iron is a +2, a +3. So this chart is always going to be a very useful tip for you to use. So these are called transition metals. The name, when you name them, needs to include what we call the charge of the metal because there are multiple charges. So you're going to use what we call the Roman numeral method. There's also a classical method, and that's if you're in Latin, you might get some of the names, and I will mention a few of them. But for the most part, we're going to use what we call the Roman numeral method. Okay, so I have 2 different compounds here with iron and oxygen. Okay, one is Fe2O3, the other one is FeO. So for this, in order to name it, I need to know what the charge of Fe is. So this is where what I was just doing before is so very important. So they both contain iron and oxygen is -2. So I don't need to worry about that. But when I look at this formula here, I see that I have 3 oxygens. And if each oxygen is a -2, I'm getting an overall -6 on the oxygen portion here. So in order to get this to 0, the iron must be the +6. All of the iron must add up to +6. So if I have 2 of them, that means that each iron is the +3 variety. Or you could deduce from down here, FeO. So this is a one-to-one relationship. So for every oxygen, I have one iron. So iron must be +2 because -2 and +2 must equal 0. So this one is iron with a +3. This is iron with a +2. So when we name them, we can't call it iron oxide because both of them can be called iron oxide because they both have iron and they both have oxygen. So this naming system is because iron can be the +3 variety or the +2. So we're going to use a Roman numeral. The Roman numeral is going to go between the names, okay, in parentheses. So this is going to get 3 Roman numerals, and this is going to get the 2 Roman numerals. It has nothing to do with how many iron are there. What it has to do with is the charge, okay? So that Roman numeral has to do with the charge of iron, the charge of iron. So see if you can name these two, CuCl2, I'll make it bigger, CuCl2 versus CuCl. How would you name those two compounds? How would you name those two compounds? So CuCl2 would be named copper 2 chloride, and CuCl would be called copper 1 chloride, copper 1 chloride. Again, what we care about when we're naming with transitions is going to be the charge of the copper. Okay, so this is the copper 2, so that's why I have the Roman numeral 2. This is the copper 1, so that's going to be copper 1 chloride. So that's how you name binary compounds. That's how you name binary compounds.